Oops. So not only it's important to note that the acceleration of these two things is the acceleration of the two blocks is also going to be the same, at least in magnitude. So what we need to determine, so this force of the rope on M2 and the force of the rope on M1 here, we could replace those with a common variable, and the one that your book would almost uniformly use would be something like tension. So we know the tension in the rope here is going to be equal to minus sine theta mg equal to m1 times the acceleration of m1. And also here, the tension minus mg is equal to m2 times its acceleration, a. All right, one of these blocks can't be accelerating faster than the other one. If it were, then that would create you would have them moving further apart, which would require more rope, right? You would need more length. If one of them was increasing, there was a larger change in velocity, it would mean that you'd need the two objects would be moving further and further apart. So now that we have a relationship here of equation 1 that has tension, sine theta, we know what theta is, we know what the mass is. Oh, I wasn't very careful about labeling these masses. This was from All About Mass 1, so this actually was M1, and this was the Newton's second law that we wrote about M2. All right, we now have two equations and two unknowns. There's our second equation. We can now substitute in and determine an answer. One very quick way to do that, a lot of times you would solve for t, for instance, and plug that in. One thing that you could do is simply subtract this whole equation from this equation. So we take the whole left side and we take t minus sine theta mg minus t then plus m2g. So we could take, the t's would cancel, t minus t would give you 0. The top equation you'd have minus sine times, or sine of theta times mg, and then we're subtracting the left sides from one another, so this would be plus m2g. I didn't vary my 1 again, there's m1. And that would be equal to the right side of the equation, which would be m1a minus m2a. Now we're going to have, we know what m2 is, m1 is, we know what m2 is, g, m1, theta. We know all the information except for a. So now we're going to be able to solve this relationship simply for a. In fact, the right side of this equation pretty clearly could be written as m1 minus m2 times a, and then we just divide both sides by m1 minus m2, and that would give us what the acceleration is, which I'm pretty sure that's what we were going for. The question was asking. I actually have to go back and find it now. And maybe it won't pop up for me. But I'm pretty sure that's what the question was asking, about the acceleration and then also the tension. So once you have the acceleration, you can plug it into either one of these equations and then solve for the tension. So I hope that's clear.